What's up, scholars? Today we're going to talk about my absolute favorite topic in geometry, proofs. It's my favorite topic, but it's not everyone's favorite topic. It's pretty challenging to think about. Why is that challenging? Because you have to answer the question why for every single thing that you say. So it's kind of like talking to a small child. You'll say something, and you got to think why. Why is that true? And you have to justify every single statement that you make. But then when you do that, you have this airtight argument that no one could possibly disagree with because you have stated why for everything that you said. Alright, cool. So, we're going to jump into an example and prove very clearly why something is true. Okay, here's the situation. We've got Batman. We've got Catwoman. We've got downtown Gotham City. We've got a fish restaurant and a pizza restaurant. And we've put some segments on top of these locations. So, what's the situation here? Well, Catwoman knows how long it takes her to get to the pizza place. And Batman knows how long it takes him to get to the fish place. And they know that's the same amount of time. Actually, we should really say distance. It's the same distance for Catwoman to get to the pizza place and Batman to get to the fish place. So from Catwoman to pizza is the same distance, not time, distance as Batman to the fish place. Alright. Now, Catwoman loves to eat some food, because who doesn't? And she knows that when she is in downtown Gotham City, it is the same distance from downtown Gotham City to the pizza place, and from Gotham City to the fish place. Right? From Gotham City to pizza is the same distance as from Gotham City to the fish place. So, Catwoman and Batman are trying to decide whether it's the same distance from each of their houses to downtown Gotham City. Catwoman, in her infinite wisdom, says yes, it is the same distance from each of their houses to Gotham City, just based off of this information. So this is the stuff that we are given that we're going to base our argument off of. And the statement we are trying to prove is that the distance from Catwoman's house to downtown Gotham City is the same as from Batman's house to downtown Gotham City. We're trying to prove that CG is equal to BG. Alright, let's think about why this might be true. This is the stuff that we know. C to P is the same as B to F, and GP is the same as GF. So we're trying to show that CG is the same as BG. Well, let's think about if we had, let's put some numbers in there. We're just doing some planning. We're just doing some planning. Let's put some numbers in there. Let's say that CP and BF are both 10. We're just pretending here, so we could think about why this might be true. And let's say GP and GF are both 3. GP equals 3. GF equals 3. So let's draw out those segments for a second. We've got B and G and F. We know this whole thing is 10, and this part is 3, just based off the numbers that we came up with so we could think about. None of this is true. This is just using the information that we were given, plugging in some numbers to try to make sense of what's going on here. And then our other segment that we have is that CP was also 10 and GP was 3. So, is it the case that CG and BG are the same distance? Well, if this is 10 and this is 3, this would have to be 7. If this is 10 and this is 3, this would have to be 7. So, yes. Okay, how are we going to prove this without numbers? Because we made the numbers up. But when we made the numbers up, it was really easy to see that it was true. What are we using here when we take two segments and add them up to equal a third segment? We're using the segment addition property. Okay? We're using the segment addition property. That's what's happening here. So our intuition says, yes, this is true. We're going to use the segment addition property somewhere. Alright, cool. Since this is our very first proof, I'm going to walk you through nice and slow. If you are getting confused, it's okay. I might watch this video all the way through and then come back and take notes. This is a tricky subject, okay? But it's awesome. Okay, so when we write out a formal proof, like I said, you have to have a reason for everything that you say. So we organize it to make that definitely happen in what's called a two-column proof. So on one side, we will have our statements, and on the other side, we'll have our reasons. And this ensures that every time we make a statement, we have a reason that goes with it. So, generally, we need to start with the information that we were given. It's very hard to build an argument when you have nothing to start with. So let's start with the information that we were given, which was that CP and BF were congruent. Not congruent, their lengths were equal to each other, right? From Catwoman to the pizza place is the same as Batman to the fish place. And what's our reason for being able to say that? It was given to us. It was given. Just like GP is equal to GF. From downtown Gotham City to the fish place was the same as downtown Gotham City to the pizza place. That's the same reason it's given. And our very last statement is going to be the thing that we are proving. CG is equal to BG. So we want to manipulate these equations to get down to this last equation. We talked a little bit about plugging some numbers in to get some intuition as to whether or not this is true and why it might be true. We said we're going to use the segment addition postulate here. So let's write this out, the segment addition postulate for both of these guys. Segment addition for the top one is going to be BG plus GF equals BF. BG plus GF equals BF. Why is that true? Well, that's segment addition. Segment addition. And at number 4, let's look at the other segment. CG plus GP equals CP. Whoops, I want to see. So I'll put it over there. CG plus GP equals CP, also by segment addition. Alright. Now we're trying to get down to CG equals BG. CG equals BG. Interesting. Okay. Let's see what we can do here. We've got CP equals BF. And we have BF equals this thing and CP equals this thing. So if CP equals BF and BF equals something and CP equals something, these somethings must be equal to each other. Let me say that again. If CP equals BF and CP equals something, BF equals something else, these somethings also have to be equal to each other. Okay, so what we're really doing is we are substituting this expression in for BF and this expression into CP. So we can now say that this expression equals this expression because of substitution. So BG plus GF equals CG plus GP. That's by substitution. Alright, why is this helpful? Well, again, we're trying to get down to CG equals BG, and now we at least have those things on the board. Right? We've got CG on one side of an equal sign, BG on another side of an equal sign. We're getting closer to what we're looking for here. But we've got these pesky GFs and GPs still in our equation. Where else do we see that in the information that we've written down? Up here. Huh, well they're actually equal to each other. GF and GP are equal to each other. Way up here where we were given. So let's take this GF and plug it in for GP in this equation. Again, why are we allowed to do that? Substitution. So we now have BG plus GF equals CG plus GF. By the same reason, substitution. Again, we're trying to get down to this prove statement that says GF equals BG. We have BG plus GF equals CG plus GF. My dog's being crazy outside. So we are close. This has CG equals BG. This has BG equals CG, but we have added GF to both parts. So let's get rid of that sucker. Let's subtract GF from both sides. Why are we allowed to do that? We're always allowed to subtract the same thing from both sides. If you think about an algebraic expression, we've got, just bear with me for a second. We had x plus 3 equals 10. We're always allowed to subtract the same thing on both sides. That maintains equality. So we can do the same thing with segments. We can subtract GF on both sides. And when we do that, we get BG equals CG by subtraction, which was what we were trying to prove, that these two segment lengths are equal to each other. Now, does it matter that the order has been flipped? No. If these are equal to each other, I could change it around. 5 equals 5, which is the same thing. Okay? They're equal to each other, they're equal to each other. So what does that mean in our situation? That from Batman's house to downtown Gotham City is, in fact, the same distance from Catwoman's house to downtown Gotham City. Alright. Okay, so what's the deal with proofs here? When you write out your proof, you need a reason for everything. You want to start with the stuff that you were given, because you're building an argument. You're trying to prove something. It's impossible to prove something if you don't have a starting point, what you're using to build your argument. So start with your givens. Do a little plan. Maybe plug some numbers in to see if it makes sense. Segment addition is a very popular tool to be used in segment proofs. You can use all of your algebra tools, like subtracting things from both sides. Okay? And substitution is also a very popular tool. Now, when you get questions like this on ALEKS, you'll be given all the statements, and you're going to fill in the reasons. Okay. Let's do another example, this time with some angles. So here's our next example. We are given that the measure of angle RVT is equal to the measure of angle SVU. So RVT, that's fine. RVT is the same as SVU. We're trying to prove that the measure of angle 1 equals the measure of angle 2. Well, let's see why this might be true. RVT, that looks like a big angle made up of two angles. So let's write that out, see what that means. RVT, angle RVT is equal to angle 1 plus angle 2. And we see SVU, the other angle we have information about that we're given. Angle SVU is equal to angle 2 plus angle 3. And then we know these guys are equal to each other. So these things will be equal to each other, right? If RVT is equal to SVU, then whatever RVT is will be equal to whatever SVT is. So we'll have angle 1 plus angle 2 equals angle 2 plus angle 3. Then this is pretty easy. We can subtract 2 off of both sides and get to what we're looking for. Alright? We could subtract 2 off of both sides, and we'll be left with angle 1 equals angle 3, which is what we're really trying to prove. Okay, so we'll use our angle addition to write this out formally, that RVT is made up of 2 angles, just like SVU is made up of 2 angles. And since we're given that those 2 angles are equal to each other, we could set what they are equal to each other by substitution. And we subtract off angle 2, and we're left with what we're looking for. Okay, I was a little sloppy here. I really should have put the measure of in front. The measure of, the measure of, the measure of, the measure of angle 2 plus the measure of angle 3. There should be little m's in front of all of these angles to mean the measures of. Cool. Alright, so let's start our proof. How do we write out proofs? In a statements and reasons column. We are math magicians. We like to write as little as possible, even when we're doing these proofs. So I just put S and R. I don't even write out the whole word, because I know that means statement. I know that means reason. What are we going to start with? The thing that we're given. We got to build an argument off of something. So let's write the thing we're given. RVT is equal to the measure of angle SVU, and that was given. Second thing we did, we wrote out the angle addition for both of these angles. So the measure of angle RVT is equal to the measure of angle 1 plus the measure of angle 2. Sorry, I squashed those up there a little bit too much. That was angle addition. Yep, that says you can add 2 angles up to equal a third angle. And by the same reasoning, the measure of angle SVU equals the measure of angle 2 plus the measure of angle 3 by angle addition. Fabulous. Slide that sucker up. Now, if these are equal to each other, I can plug whatever RVT equals in for that guy, and whatever SVU equals in for that guy. So we've got a new equation that says the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. That's by substitution. Okay. Then we can subtract the measure of angle 2 from both sides to get the measure of angle 1 equals the measure of angle 3. That was by subtraction. Okay, fabuloso! Très bien. Cool. Alright. So what did we do here? We started with what we were given. We used another very popular tool with angle proofs, angle addition. Then we used substitution, another very popular tool. And we got a new equation, and we subtracted the same thing from both sides. So by subtraction, we got down to the statement that we were trying to prove. All right, that's it for your intro to proofs. Go slow. Ask me if you have any questions. I love this stuff. I find it very pleasant making these airtight arguments about beautiful geometry things. So keep on that hustle, and I will see you next time.